Okay, so in today's video, we are solving trig equations once again. So remember, the answer to a trig equation is an angle. Right? The answer is always an angle, or in most cases, angles, right? Plural. There's only a few cases on the unit circle where we only have one angle, right? For sine of 1 and cosine of 1 and negative 1. Those are really the only ones that have one angle. Okay, so let's do this. We're going to solve this by doing our elementary math first. So elementary math says add 1 to both sides, because if this is where your variable is, you want to isolate your variable. So 3 cosine of x equals 3. Right? So here x represents your angle. X is representing an angle in this case. So divide both sides by 3. The cosine of our angle has got to be 1. And then our last step is to get the cosine away from the 1, or rather from the x. And we always do that by taking the inverse cosine, or the inverse trig. Okay, that's how you get x by itself. That's how we isolate your variable, is by taking the inverse trig, in this case the inverse cosine, of both sides. Now, we need to understand what this is asking us to do, right? We are being asked to find the angle where the cosine value is 1. And we go to our unit circle to do this, and hopefully you have a unit circle handy and can find out that this happens at 2 pi. Okay, yes, it does also happen at 0, but our directions say that we are not going to include 0, right? It says theta is greater than 0. So we're not going to include 0 in our answer choices, but we will include 2 pi in your answer choices. So the cosine of 1 is going to happen at 2 pi, and that's the only place on our unit circle where the cosine has a value of 1. Okay, so we do our easy stuff first, our elementary math first. This says to subtract 3 from both sides, right, to get 2 times the sine of x equals negative 1. And then we're going to divide both sides by 2 and find out that the sine of x equals negative 1/2. Okay, and then our shortcut says that the angle x, right, x is an angle, is going to be the inverse sine of negative 1/2. In other words, what are all the angles along the unit circle where the sine value is negative 1/2? Okay, so if you have your unit circle handy, we're looking at the y values as you go around the unit circle. And the first one where the y is negative 1/2 is 7 pi over 6. And that's our third quadrant angle, because sine is negative in the third quadrant. And then our other place is 11 pi over 6. Those are both of the angles on the unit circle where the sine has a value of negative 1/2. Okay, example 3. 6 times the cosecant of x is 4 roots of 3. Okay, so we're going to get rid of this 6 by dividing both sides by 6. Okay, so the cosecant of our angle is, let's reduce this. 4 over 6 reduces to 2 over 3. Okay, so then our angle is all the places on your unit circle where the cosecant has a value of 2 roots of 3 over 3. Sorry. Now, if you don't have your cosecants memorized, cosecant is the inverse of the sine. So we're looking for all the places on your unit circle where the sine is root 3 over 2, right? Because these things are reciprocals. If you don't have your cosecants, your reciprocal trigs memorized, but you do have your sine and cosine, then you can always convert your cosecant value to a sine value by doing the reciprocal. Okay, so 2 root 3 over 3 is the reciprocal of root 3 over 2. And this happens at pi over 3 is the first angle where the cosecant is 2 roots of 3 over 3. And it also happens at 4 or nope, 2 pi over 3 is the next place where the cosine is positive and thus, the cosecant is positive. It happens at pi over 3 and 2 pi over 3. So that's your solution. That's the angles that will make that possible. And then our last one, look at this. We have these funny looking radicals. So let's talk about how we do radical subtraction. We're going to subtract 4 root 3 from both sides. Okay, now I know, because I saw this happen earlier today, that the temptation is to subtract, right, part by part, to subtract the numbers and to subtract the radicals. Well, that's not how it works. Okay, this is really how it works. What we do is we have 3 roots of 3, right, is literally a group of 3 roots of 3. Okay, so that's 3 root 3. We have 3 root 3, just like you have 3 dogs, or you have 3 hamburgers, or you have 3 houses, or 3 cars, or whatever. Right? So 3 is like root 3 is a variable, and we have 3 of them. And then we're coming in with negative 4 root 3s. So here is a negative root 3, and then a negative root 3. Right? We have 4 negative root 3s. Okay? And every one of these cancels out with every other one of them. So if we do 3 roots of 3 minus 4 roots of 3, we have negative 1 root 3 left over. Right? So you don't actually subtract the radicals whatsoever. The only reason we're able to subtract these at all is because they have the same radical. Right? If this were a root 2, then you couldn't subtract them because the radicals don't match up. So because the radicals do match up, we actually only subtract the coefficients. Okay? Because 1 root 3 cancels out with 1 negative root 3, and we have a negative root 3 left over. So that's how that works. So we are looking for all the places on the unit circle where the tangent has a value of negative root 3. Okay? Tangent has a value of negative root 3. And those angles are, let's see, the first one is at 2 pi over 3. Right, in the second quadrant, that's where tangent is negative. And also in the fourth quadrant, we have 5 pi over 3. That is another angle where the tangent is negative. Right, tangent is negative in the second quadrant and in the fourth quadrant only, because your x's and your y's are different. Right, one's plus and one's minus. So when we're solving for our trig equations, we do our elementary stuff first. We subtract away from the trig, and then we divide, and then of course the formal thing is to take the inverse in order to find the angle from your unit circle where that specific trig has that specific value. Okay, hopefully this helps and you have a better understanding of how to solve trig equations.